Alright, gentlemen. I want to be able to walk you guys today through how to construct a Bohr model diagram for an element on the periodic table. And so remember, we got to go to those 5 steps. If you don't remember those, you can pull up your PowerPoint, pull up your notes, and you can look at those. But I want us to construct a Bohr model for neon. Element neon. Okay, so that's the question. And so we got to think to ourselves, what pieces of information do we need in order to produce this Bohr model for neon? Now, if you remember, the very first thing that we needed to do is we need to find it on the periodic table. Okay, and so I want you guys to pull out your periodic tables. You can open them up, and I want you to look for neon. Okay, now you should have found it by now. Neon is element number 10 on the periodic table. So it should be on the far right-hand side of the periodic table. So now that we have found neon, we need to look at its atomic number. Now, its atomic number, Z, equals 10. That means that it has 10 protons, and it also has 10 electrons, right? So if its atomic number is 10, it means it has 10 protons, 10 electrons. So now we found it on the periodic table. We have identified how many electrons it has. The next thing that we look through is we have to look at what row it's on so we can figure out how many energy levels it has. So on the periodic table, you should see that neon is on the second energy level, second row, so it's got 2 energy levels. Okay, now because we've been able to identify that information, we can go ahead now and we can start to construct our Bohr model for neon. Okay, so now we've got a new screen here, and anytime you start your Bohr model, I'm just going to kind of rewrite up here. We're dealing with neon, and we know that we need to use up 10 electrons. Okay, and we know that we have 2 levels that we're going to include. Okay, and so the first thing we're going to do is we're going to draw the nucleus of the atom. Now, for our purposes, the only thing I really need you guys to do here, just kind of draw a circle that's in the middle. Okay, now because we know that we have 2 energy levels, then what I'm going to do is I'm going to go through here and I'm going to draw one ring, and then I'm going to draw a ring that's a little bit bigger than that ring. Okay, and so those 2 rings represent the energy levels that are going to hold electrons for neon. Now, the first energy level is the one that's closest to the nucleus. So this one right here is number 1, and then this outermost one is number 2. Okay, and if you recall, each energy level has a maximum occupancy. And so the first energy level, that maximum occupancy is 2. So of my 10 electrons that neon has, I'm going to draw two electrons on that first energy level. Okay, and I'm going to represent those with some big dots, right? So dots equal electrons. Okay, now we only put 2 on the first energy level, and we start in the first energy level because we fill up the ones that are closest to the nucleus first, and then we make our way out. So we put our maximum number of 2 in the first energy level, but now of our 10, that means that we have 8 left over. So now I'm going to move to the second energy level, which holds a maximum of 8 electrons, and I'm going to start filling that up. So I've got 1, 2, 3, 4. Now remember, we've got 8 left over. So then I've got, what's that, 1, 2, 3, 4. So then that's 5, 6, 7, 8. All right, so I ended up putting the maximum number of electrons that I could fit in energy level number 2. Now we count those out. We got 1, 2 on the first energy level, and then 1, 2, 3, 4, 5, 6, 7, 8 on the second energy level. That gives us a total of 10 electrons. This would be our Bohr model. So this is our Bohr model for a neon atom. Pretty cool, huh?